Have you ever thought about how are the Flutter project setups done for the production, or do you ever want to set up a Flutter project in a clean and a maintainable way so you don't have to worry or you don't have any difficulty maintaining the project when the project actually grows? From my experience on building the Flutter apps, I have came up with this course where you will learn everything that is needed to set up a Flutter project for your production application. And this will be a door opener and will be really helpful for any Flutter developer who are preparing to get or searching for a new jobs on the Flutter side. And also it will be really helpful for any Flutter developer who already has a job, and this can really give a boost to their career and confidence. So let us go and see what you will be learning in this course. In my classroom, you can see I have a first section where I introduce myself, and you will have a course syllabus and a repository. And then we have a clean architecture part where we will be learning clean architecture regarding the layers, how the clean architecture are setups. We'll also learn about the separation of concern principle, and also about the controller service and the repository pattern. After that, we will learn about the solid principle, where we will cover all of the 5 principles from the solids. This will be really helpful if you want to be a better developer or if you want to understand the project more clearly. And the third section, we will be learning how to set up our Flutter project. So here we will be learning about like setting up the Flutter project, creating your GitHub repositories, and like setting up your workflow strategy, and how to set up the version management, right, setting up the flavors in the Android and the iOS, and how the code signing is done on the iOS as well as on the Android, and also configuring a multiple environment for your development, QA, UAT, and the production. We'll be also using a translation and configuring a lint. Also we'll be configuring like the internet connectivity observers, logging, and all of those stuff. And on the fourth section, we'll be learning about the Firebase integration, where we will be using a Flutter Flyer, configuring the Crashlytics on the Android and the iOS, as well as configuring the like the push notification, and configuring the push notification on the Android as well as the iOS. And also we will configure the image notification, which is really difficult to configure on the iOS side, as well as we'll be looking into deep links on using the Firebase dynamic link, and also the Firebase performance. So using all of this concept, you will have a base setup for your Flutter project, where you will have a really easy time maintaining when your Flutter project actually grows. Because in the large project, you need to have some kind of the proper setup architecture, and you need to apply some principles, so that when your Flutter project actually grows, you have easy time maintaining all of those stuff. Whatever I have covered in this course is from my personal experience building the Flutter application, and I have applied all of this concept in my Flutter application, which helps me to build and maintain a large scale application. So I hope you will join this course, and if you have any question, do contact me. I will provide my email address down in the link below, as well as the course link. So see you guys. Let us look into the third principle, which is the L, which stands for the Liskov substitution principle. And this was initially introduced by the Barbara Liskov. As the name you can see, Liskov substitution principle. So this principle got the name from the Barbara Liskov in the 1988 conference keynote. She had addressed about this particular principle. And if you are coming from the object-oriented programming background, you should be pretty familiar with the inheritance. So if you are following this particular principle, you will be doing your inheritance correctly. And if you don't follow this particular principle, your inheritance is always incorrect, or it it's always messed up. So if you want to have a proper inheritance, you should always follow this particular LSP, or the Liskov substitution principle. It says that the superclass should be replaceable with the object of the subclass without breaking the application. So when you are having a parent and a child class, and when you are having a relationship of the each relationship, your parent class should be replaceable with your child class without breaking any application. In other words, we can say that you want your subclass to behave the same way as your superclass, or you want your child class to behave the same way as your parent class is behaving. So it may be a bit confusing over here, but when we do it practically, you will understand what I actually mean over here. So let us get into the practical, and let us create a practical project. Okay, so I have created one folder which is of LSP, or Liskov substitution principle, and we have two folders inside it. One is of a problem and another one is the solution. So inside the problem, let me create a new file and call it as a main.the file, and let's create a main function from here. And I'll also add a new file and call it create a car.the file, and let's create a class of the car. And let's have some functionality for this particular car. Okay, what it happened over here, and let's have a function, so a void, and let's say a car can drive, right? So drive, and let's say a print, and I can just car can drive, and then let's create another function, and let's say a void do brake. A car can break, brake. So a car can brake. So let's say a print, and I'll just say a car can brake. Let's say a car, and it will also have let's say a petrol, right? Void fill petrol, and then petrol petrol, right? So what happened over? Okay, so petrol petrol, and let's say print over here, and then print print, and let's say a car can fill petrol or something like that, petrol petrol. So we have a car can fill a petrol. Maybe you have a car and also it can do something like fill let's say a gas, right? Void and the fill gas, and let's say a car, sorry, it should be of a print function, and the car can fill gas. Let's create one more function of a void, sorry, it should be of a void, and let's say a recharge, or we have a recharge battery. So let's say if it's an electric car, and print, I'll just call it as a electric car can recharge the battery, and then I guess that should be fine. And I have a spelling, so electric, right? Okay, so I need to remove this one too. So let's say we have this car class, and now you can see it can drive, it can do a brake, and it can do fill a petrol, gas, and the recharge a battery. So let me have one more file, and let's say this is petrol car and the file, and now I have a class of the petrol car, and this petrol car we will inherit from our superclass or the parent class. So I call it as extend from the car class. And once I have that, what I can do is over here I can go and drive. I will override the drive, and let's say petrol car can fill the I cannot fill the gas, I can fill the petrol. And then let's say I can fill maybe I can fill, or I can do a brake, right? So do a brake. I can also do a brake. And what else? The functionality is to fill a gas. Maybe some car maybe have a tool like a fill a gas as well as the petrol at the same time. So maybe it's running on, sometime it may run on the gas and sometime it may run on the petrol. So it's a modification, right? So fill a gas. So maybe we have this all of this functionality for this particular petrol car. And now you are not currently seeing the problem, but let me show you it a bit later. So let me create a one more class, and now I can have a new file and call it as a I can call it as a let's say gas, or let's create a electric car, right? Electric car. And let's create a class of the ELA3 electric car, and this extends from the electric car, it extends from our car class. Okay, it should be here. And electric car and class extend this different superclass. Why is that particular car? Okay, car is there, and the electric car, why is that car cannot extend from here? Import the car. Okay, that's good. So we fix that error. Let's say this electric car can do a brake, right? And it can also like drive. And then I will override another like a recharge. We need to recharge a battery, but and other than that it doesn't have to fill a gas. And then let me just copy. So it may also recharge a battery as well as maybe a petrol. If it is a hybrid, like maybe it can also have a petrol or the battery. So let's say this is just electric car which doesn't have both of this functionality. And now if I go to if I have a function like fill the gas, and this functionality is not there in this particular electric car, because fill gas, it doesn't require the electric car doesn't have a functionality to fill a gas, right? So I'll just print over here, and I'll just call it as a let's say electric car, right? So this particular car, just copy this. Electric car does not have this function, or yeah, let's say we don't have that functionality. So now if I go to the main, and if I have let's say a final variable of the let's say a car1, which is of equals to the petrol car, right? So PET petrol car, and then I can have a car1 dot I can get the do brake or drive, right? And I can car1 dot I can have let's say a fill a petrol, and then I can car1 dot, and then the problem is that I don't need to recharge over here. A recharge battery is not acceptable over here. So the problem you can see over here is that this car is a superclass or the parent class, and it has all of the functionality that we need inside a car. I fill petrol, fill gas, do brake, drive. But if you have a petrol car, and that doesn't require the battery functionality, and maybe fill a gas. And if you see electric car, it doesn't require fill a gas or fill the petrol. I just need to have a recharge a battery, and this doesn't require over here, or you may throw an error, or you may say it's not defined. The point over here is that when we saw this Liskov substitution principle, we saw that the your drive class or your child class should behave exactly as your parent class. So whatever functionality is in the car class, if you are extending that particular class, like let's say if in the petrol I'm extending from the super class, which is of the car class, if I'm extending from that, I should behave same as this car, and I should have all of the functionality of that particular car. It's not that some of the functionalities that I have and some of the functionality I don't have. So whatever the car has functionality, your petrol car should have that. You should implement that function, whether it's a drive to drive, it's to fill petrol or recharge the battery. So all of the functionality that car has, you need to have it. If you don't have, then you break that particular principle, which is of the Liskov substitution principle, which says that your child class or your drive class should be always behave the same way as your parent class. So it should be interchangeable. So your car class, petrol, your petrol car, and your electric car should behave as a car class, right? And that means that we are breaking this rule currently, because some of the functionality that was in the car class, we are not implementing it over here. So we need to find a solution for this one. So how we can follow this particular Liskov substitution principle. So if you are having this kind of situation, we need to find a solution. So let's go and let me create, or let me copy all of this, I guess. Let's see, I just copy this over here, paste it, and then I will have one more, and which is of let's say electric. All right, electric, and then the dart file, and then we have one more file, which is petrol the dart file, and then we may have one more, and that is of the gas.the dart file. So let's create a class for this one, and let's call it as a gas, and let's have this petrol, and I will call this one class as a petrol, just petrol petrol. And let's have this particular electric, so class electric. And what I made a mistake, I guess it should be a spelling mistake, so electric. And now if I go to this car, and what I need to do is I will just cut this one, and I will put inside the petrol, right? So the petrol is the one that we need from here, and then we have a fill petrol, and that should be fine. Okay, what happened over here? Why did I make it over here? So it should be of the petrol, right? And then we have a gas, and inside this gas I'll just copy this fill gas, or just cut this section because we are not going to use it over there, and I'll just paste it over here. And then I have finally recharge the battery, and I'll just cut this one too, and I'll go to electric, and in the electric I may recharge a battery. And then now if I go to car, this car has only two functionality now, which is to drive and to do a brake. So now we separated it in the different classes, right? So gas, electric, car, petrol. So we have multiple classes. Now if I copy this electric car, and also if I copy the petrol car, just paste it over here. And now in the electric car, if you go over here, this electric car can extend from the car, right? But it doesn't have the functionality of these two. So I'll just remove these two. And now the electric car can just need the car, as well as you can have the option to electrics. It can also use it recharge the battery. So what I can do is I can just go to the electric car, and I can also extend. So I cannot extend a multiplier class over here. So what I need to do is I need to have another class. So let's say I'll call this one as electric car implementation, and I'll create another let me rename this one and call it as IMPL, right? And let me create another class. Just copy this and just create a new file, and I'll call it as electric car dot file. And this one I'll create an abstract class of the electric car, right? And electric car, and this will electric electric car. And let's have a functionality of let's go to the electric car, and I can extend from here. Let me go to the electric car and extend, or let me paste this one. I will implement from the car, right? So let me implement from the car, and let me import from the car, and also I need to implement from the electric, right? So now I have a 2, and then what I need to do is I need to override the functionality. So I can just go over here, and now I can extend from the electric car that we just created. So electric car, yeah, and I can just remove this functionality, and now I need to implement all of the 3 missing functionality. So now I have all of this. So do brake and do drive, right? And then I have a functionality of the battery. So let me remove this one, and also over here it's not required. So so we have this particular functionality over here, do brake, drive and recharge for the electric car. And similarly for the petrol car, what we need to do is let me create I guess I will not need this one. So what I will do is I'll create a new file. So petrol underscore car underscore implementation, and this is a .dot file. And for this petrol car, I will make it as an abstract class. And this one will extend from the car, as well as it will also extend from the petrol, right? So petrol. Okay, so I don't need I need implementation, not the that one. So petrol. So I'll just remove all of this, and now I don't have to do anything. So let's go to the petrol car implementation. So let's create a class over here, class, and the Petrol Car Implementation, and this car will extend from our petrol car. So petrol car, and now I need to implement all of the missing functionality. So 3. So now I can do brake, drive, and fill the petrol. So similarly, you can have the another car which is of the a gas car, right? So let's say I can have a new and the gas car .dot file, and then I can create a class of the let's say gas car, and this will implement from our let's say a car, and also from the another one is a gas. Now this should be of a abstract, maybe strct abstract class, and then I can go to the I can create a new file and create a gas underscore car underscore the implementation and the dot file. So let's create a class of the gas car implementation which extends from our gas car that we have. And now I need to implement all of the missing functionality. So now this gas has an option to brake, and then do a drive, fill a gas, and the fill a petrol should not be there. So I guess I imported the wrong one in the gas car. So gas, it should not be from the problem. So it should be from the car, right? So I'll just have to import this particular car. And now if I go to my gas car implementation, I don't need to have these two, right? So that is not there. So now you can see that our gas car or you have the petrol car implementation, it is just doing the same thing that whatever is in the petrol car. So if you go to the petrol car, and then you have the implementation from the car and the petrol. So whatever the car has, the your child class has the functionality. So this way you can separate it and do the correct inheritance. So your child class or your drive class will behave or exactly same as your parent class. So let's say you have a gas car and it has the implementation of the car and the gas, and when you have the child class, which is this particular implementation class of the child class, it is actually doing the same thing as the gas car is doing. So even if I make a new file and have a main dot file, sorry, main dot file, and you have a main function main function over here, and a final, let's say car one, which is of equals to a gas car implementation, and the car one dot, now you can do a brake, drive, fill, gas. So that's it, you don't have to have any other functionality, right? So which means that you can do a brake over here, right? And this class can be from any of your parent class, like the gas car, right? And then it's behaving same as the gas car, right? So whatever gas car has the functionality, your gas car implementation has implemented all of those stuff. So it's quite long, but I guess you got the idea about the inheritance doing in the right way. So when you are creating when you are inheriting from the parent class, make sure that all of the functionality of your parent class is implemented by your child class, which means that all of the functionality your child class should behave exactly as your parent class. So if some of the functionality that you have in the parent but that is not there in the child, then you are breaking the rule of the principle of the Liskov substitution principle. If you have a child class and you have a parent class relation, each relationship, make sure you have this principle followed. So your child class should behave exactly as the parent class. So whatever the functionality your parent class is providing, your child class should provide it. You should not skip any of the method, like it's not implemented or throw some error. You should not do that one. That will actually break that particular principle. So that's it. Let's meet up in the next one. Till then, have a great day.